Good evening, everyone. Welcome to the third week of online discussion on problem solving for wastewater treatment and recycling. My name is Maniyatnam Prakash, and I hope you are able to listen my audio. Am I audible to you? And can you see my screen? Please confirm once. Those who are available, please confirm that whether I am audible to you or not, or and also yes, okay. And I think you can see my screen also. Hmm. So, okay, thank you, Rahul, thank you. So, today, my name is Manitnam Prakash, and as stated earlier, that we will be meeting every Tuesday from 7 p.m. to 9 p.m. And the link which has been already shared with you, and the recording of this session will be uploaded on this YouTube channel. The link for which has been already shared with you. So in week 3 we have gone through basically quality parameters. So in first week we came out to know about the what is wastewater. In second week, how to estimate the wastewater. And remember, our final aim is to treat wastewater not at the current moment but for next 50 years. So so one should know what kind of wastewater is coming to our ground or our treatment plant. Depending upon that quality, we will be planning our treatment method. Okay, now. So in week 3 we have read about several quality parameters, and I hope that those who are available here must have gone through the video lectures uploaded on the NPTEL, and the questions which I am going to discuss from the next slide are based on based on the course that has been taught to you. So we will see what is the basic parameters like turbidity, calorimetry, then different demands, dissolved oxygen, COD, and everything. And what are those? What are those? And what are those? What are different parameters that is used to define that particular term? Okay, and then we will go through some practice problems based on the some of the theoretical thing that we have read. Okay, so as usual, I will be showing some question, then I will be giving some around 30 seconds of time to solve it, to solve, so that you can solve that question, and we can have discussion based on that. Okay. So if you have any problem, you can write it in the chat box, or you can just unmute yourself and you can speak. My laptop is also working fine now, so I hope I don't face any problem today, and we can have the discussion in very smooth way. Okay. So the coming to the first question, the it's very simple question. So I request everyone who those who are here, please join, please participate in the solving session. So turbidity in water is usually measured on. So there are four options. C, measuring rate constant, gravimetric measurements, detecting a scattering of light passed through the water, detecting potential of conductive electrometer. So yes, this was very simple question. So yes, the correct answer is C. That is detecting the. So turbidity of the water is defined as a scattering of light by particulate or colloidal matter in the water, given water a turbid appearance. So if you have seen some water may look hazy in the nature, so that is only due to some colloidal particle or the particulate matter that is in the water, which gives. So it can be for wastewater or for normal drinking water also. Our water is also turbid. Okay, now the turbid water have an it's like it does not look good and suitable for the. So here I am discussing about the drinking purpose, but if you look at the wastewater also, it looks like there will be some turbidity and it won't look good. Okay. So additionally, turbid water may also contain high concentration of microorganism and suspended solid. Okay. So here is the some of the like things about turbidity. So Yes, the correct answer was detecting the scattering of light passed through the water sheet. But you should know that our turbidity meter, which is used to measure the turbidity, can be of two types. One is nephelometer, when the light passes through sample and the detector is kept at there is a light source, then there is a detector. Okay, na. So that is like, so here you can see that detector is not in the line of sample. It is kept at 90 degree, so that instrument is known as nephelometer. Okay, na. So here you can see the turbidity meter is based on the comparison of amount of light scattered by the sample, define the condition with the amount of light scattered by the standard reference. The standard light from the sample can be measured by the light detector placed at the right angle to the original light path. So this was the original path, and the light was measured at the 90 degree. Okay, now that is right angle. So this will be known as nephelometer. Okay, now so I hope like you might have seen turbidity meter. It's a simple like mobile phone, like it will be like in the shape of mobile, but it will be little bit thicker. So you put your sample in that instrument, you press it, and you get your reading. Okay, na, and that will tell you the turbidity. So depending upon how light is detected, whether, so if it is detected at 90 degree, then it is known as nephelometer. Okay. Now here you can see that turbidity meter can be also by shining the light through the sample and measuring the degree of light penetration as measured by the light detector placed in the path. So here you can see the light is passing, and we are placing the detector, or known as photo tube. So that will be known as turbidity meter. Okay, now so these are two different instruments. So generally basic question that is asked, that what if the light source is at, well, sorry, detector is at 90 degree, then that will be nephelometer, and if it is at 180 degree or in the path of light, then it will be turbidity meter. Okay, coming to the second question, the spectrophotometers are typically used to measure redox potential, color, conductivity, and TDS. Yeah, all of these. B. Yes, B is the correct answer. Actually, see, this like options are in like in a sense, like yes, it measure color, but actually it measure absorbance. Have you heard of anyone absorbance? What is absorbance? B is the correct answer. So like let's see. The spectrophotometers are primarily used to assess the color of sample by measuring absorbance. Okay, now. So it does not measure directly color. It measures absorbance. So it's like indicative of color thing. Okay, na. A is equal to ECL. Yeah, correct. So that is Beer Lambert's law. I will be discussing it. So there is a particular formula to find out this absorbance. So this is crucial in determining concentration of certain compound in water or the sample that is absorbs light within the visual range or ultraviolet rays. So colorimetry is used to, like, see, colorimetry is use of human concentration and length. Length of what? Length of what? What are you saying? Sample? Let me remove this thing. Sample tube. There is a specific term used for that thing. Not sample tube. Cuvette. Yes. The perfect answer is the length of cuvette. And in more sense, the path, like light path. Okay, now, so this is like, I'll be showing the formula. So this is the absorbance formula. So this is known as Beer's Lambert law. Okay, na. So this is path. So like you can say length of the cuvette or the path length. Okay, na. So your cuvette length can vary. The basic, or in more sense, either you can say the length of cuvette, or you have to say the path length. Okay, na. So what we generally do, that we put our sample in one cuvette. The cuvette length can be anything. The light is passed through it. Okay, so depending upon the how much the light is passing, be like, that is representative of B. Generally it is 10 like it can vary 1 centimeter, it can be anything. Okay now, so the basic law is the Beard's Lambert law, the linear relationship between absorbance and the concentration of absorbing species, that is A is equal to capital, it can be anything. In general, it is 1 centimeter. Yeah. So A is the molar absorbability. Remember the unit L by mole into centimeter. C is the concentration. B is the path length. So remember one thing. The absorbance is a unitless quantity. Okay, now it does not have any quantity. So if you put A L by mole into centimeter, B will be concentration mole per liter, and C will be length. So if you cut it, so A will be like, it's a unitless quantity. Generally people ask this what is molar absorbability, so you have to say that length per mole per centimeter. Okay, so a spectrophotometer is the instrument that measure the amount of light absorbed or intensity of the color at the given wavelength. The intensity of the color given by comparing the amount of light prior to the passing. So I hope you have understood this. So remember, generally people say that so if you look at this formula, people will say, yes, log I not, why I not, what are you saying? Like, see, you don't have, like, that is different thing transmitted here. So one statement will be asked to you: does this absorbance is directly proportional to concentration, or each concentration is directly proportional to absorbance? What will be your answer? My question is absorbance is directly proportional to concentration? Have you ever heard of like how fluoride is measured in a spectrophotometer? Fluoride F minus. So if you, like, if you say that absorbance is directly proportional to color, so you will get this linear what do I call, you will get the calibration curve in a linear way, that higher the concentration, higher so this is A absorbance, and this is concentration. Okay, so here if you see, for most of the case, what will happen, that less the color, less the absorbance, more the concentration, sorry, more less the concentration, less the absorbance, more the color. So if you look at this formula, this is fine, but remember, this is not true for fluoride. Fluoride is like I'm just giving in the brief. So there is a method known as Spandans method, Spands. Okay, Spandans method. So where what we do that, we add fluoride water in one reagent known as spandens, that contain zirconium. Okay now, so in that case, what you will find out, that this law is inversely proportional. Here what you will see, that the more the less the fluoride concentration, more is the absorbance. Higher is the fluoride concentration, less is the absorbance. So remember this thing. What you are saying, yes, yes, is correct, but that is not correct for fluoride. I hope you have understood it. Okay, any doubt in that? In this? No, sir. Okay. Coming to the question number 3. At 0 degree Celsius, it's 0 degree Celsius. temperature and the saturation dissolved oxygen level in water is approximately at 0 degree Celsius and atmospheric pressure, normal pressure. What will be the atmosphere? What will the dissolved oxygen? Yes, it will be 9 milligram per liter. So remember, dissolve concentration in surface water. So reduction, like these are some of the question. So if there is a healthy surface water body, it will have a concentration of 8 milligram to 9 milligram per liter. Groundwater, the water which we take from our ground surface, the concentration is around, the DO is 1 to 2. Low DO generally indicates that our water is polluted. So the question was, so if you like, there has been many research and this thing has been found. If you increase the temperature, you can expect that there will be decrease in DO, because all the oxygen that was in the water will start escaping. At the low temperature, you will see the very high amount of DO, because the water will be try to the sorry the oxygen will try to stay in the water. There will won't be any movement. Okay, thanks for so take this thing in mind that at 0 degree it will be around 14, and as you start increasing, the DO will start decreasing. And you should know the region also, like at higher temperature you will see higher movement in the gases that is present in the water, and it will start try to escape from the system. Kinetic energy will start to increase, sorry. Okay. So the correct answer was A, that is 9 milligram per liter. Now, this is very like normal question related to the past previous one. Okay, na. So the DO vary with the water temperature and altitude. As cold water holds more oxygen than the warm water, and water at lower altitude holds less oxygen. Cold water holds less oxygen, and warm water, similarly cold water holds more oxygen than warm water, and water at lower altitude hold more oxygen than at the higher altitude, or D. So I have got two answer, one is saying C, one is saying, yeah, this is true. Like if you have gone through this chapter, this figure, the first, like at lower temperature it will hold more oxygen. Okay, so the either A or C, B and D cannot be answered. Now just think about the altitude. Okay, now we have got. So I think everyone have. So first was it like effect of temperature. As the temperature of the liquid increases, solubility of gas decreases. This is because higher temperature provide higher. Just 1 minute. I am in. Hello. I am in class. I'm in class. I will call you after 9. Sorry. So you can see that this thing. So I have discussed this thing earlier also, that it will start increasing if you increase the temperature. More energy will be to more energy will be given to the gas molecule, and it will escape in the system. Okay, so the colder body will have higher oxygen. Okay, so coming to the effect of pressure, direct pressure. As the pressure increases, the solubility of gases in the liquid also increases. High pressure pushes more molecules into the liquid, increasing the concentration. Okay, na. So that's why you can see that at higher altitude, where atmospheric pressure is low, the dissolved oxygen level in the water increases. Conversely, in the deep water under high atmospheric pressure, the gas solubility increases. So the correct answer was C. The cold water holds more oxygen than the warm water, and warm water at lower altitude holds more oxygen than water at higher altitude. Okay, I hope this is clear to you. One there was one person who was saying A, Amitav. I hope it is you have understood this. Yes. Okay. If anyone have any doubt, you can ask in the chat box or you can. Oh, so sorry for the animation here. The pH of the water sample is was measured at 6.4 unit. Okay, na the major total alkalinity and the major total acidity of the water would be. Try to answer this question. There was there was one sample whose pH was around 6.4. What will be the total alkalinity and what will be the total acidity? A B C D. What would be the answer? A D. How can we acidity is simple? pH is 6.4. The acidity cannot be zero. This cannot be your answer. This cannot be your answer. So either answer will be B or D. Similarly, uh, no, B cannot be the answer. B cannot be also the answer. You have, how can be alkalinity zero? What is first? Can anyone tell what is alkalinity in theoretical? Like theoretical, I think everyone know the acid neutralizing capacity is known as alkalinity. So remember, alkalinity is always due to either bicarbon, that is caustic alkalinity, that is due to hydroxide, or it can be due to carbonate, or it can be due to bicarbonate. Okay, na. So as the pH is 6.4, so pOH will be how much will be pOH? If the pH is 6.4, what will be the value of pOH? Anyone? If the pH is 6.4, how what will be the pOH? Very simple question. I hope everyone know what is this pOH. Hello,
It may be penalty alkalinity.
what are you saying?
It's maybe a penalty alkalinity or penalty alkalinity.
No, this graph is like this graph I have not explained right now. I am just simply asking if the pH is 6.4, what will be pOH? Not minus. Why it will be minus log 6.4? I will come to your question after some time. So I have asked one simple thing: if the pH of a system of water is 6.4, what will be its pOH? We know that in our water we have H plus. Sorry for I don't know, H plus, and we have OH minus. Everyone know this thing, H minus. Huh? Okay na. So if you like, if for pure water, we know that if you multiply the concentration of H plus into OH minus, that is H plus H into, I'm just writing H into OH concentration. Okay na. It will come out to be, what will be the product of H plus into OH minus in our water? 10 की power minus 14. Does everyone know this thing or not? I mean, I'm guessing that everyone knows. Yes. So like, so if you like, if you take the log on the both side, if you take the log on the both side, then it will be log pH plus log OH is equal to minus 14. And we know that minus log pH is equal to, and minus log H plus is equal to pH. So it will be pH plus POH will be how much? pH plus pH plus POH will be 14. So if the pH is 6.4, what will be the POH? POH will be 7.6. Correct. It will be 14. So I was asking what is the POH of the system. So POH will be 7.6. 7.4 या 7.6.3. Yes, correct. So at this, so this is like POH. So means how much is the pH plus concentration? H plus concentration is 10 की power minus 7.6. Okay na. So this much. So there will be some caustic alkalinity. So total alkalinity we cannot be also zero. Okay. So if you don't have this option, so right now I can mark my answer as D. But you should understand at pH 6.4. Now I will be coming to this graph. We know that when we open our water, so generally the alkalinity is due to either OH minus carbonate alkalinity and bicarbonate alkalinity. Okay, na. I hope that was like I have erased it, but that is clear to you. pH plus POH. I don't know why you have written minus log 6.4, but that was incorrect. So now remember that in our atmosphere we have CO2. Okay, na. In our atmosphere we have CO2, and when we keep any water, there will be some dissolution of CO2 in our water. So this water, this CO2 will convert into three things. That is, some form will be dissolved into H2CO3 star. That is aqueous H2CO3. Someone will convert into SCO3 minus, and someone will convert into CO3 minus. That all depend upon the pH of the system. Okay, na. So remember, this is a graph which indicate at what pH. Now imagine that if the pH of this water was around 8, just imagine that it has a pH, so it will come around at this pH. So if you stretch this line, so this is alpha 1. So alpha 1 is corresponding to HCO3 minus. So as all the CO2 that has been dissolved will convert into HCO3 minus. What was the pH of our system? 6.4. So that will come around here. So at this point, both this alpha note and alpha 1, that is bicarbonate and carbonate, sorry, HCO3 minus bicarbonate or and carbonic acid will both exist. So if the pH is 6.4 and we know that there will be CO2, so again there will be some amount of carbonate alkalinity also, and sorry, some there will be some bicarbonate alkalinity also. The amount of carbonate will be also present, but that will be very less. Are you understanding what I am saying? So this graph is known as log CpH curve. The distribution of carbonate species as a function of pH. The carbonic acid is a diprotic acid with pK1, that is 6.35. That is after 6.35, this H2CO3 will start dominating, and pK2 10.33, means between 10.33 and 6.35 this bicarbonate will dominate, and after 10.33 this carbonate will dominate. So this is very important graph when you are doing some kind of like, when you are reading about alkalinity and all this thing. So again it will contain some H, it will contain some carbonate, bicarbonate. Okay, so we know that alkalinity. So at this pH there will be some carbonate. So those who were saying B were also incorrect. So the correct answer will be total alkalinity will be greater than 0. Total acidity will again at this 6.4 Again, we know that there will be some H plus. What will be the H plus? That is 10 ki power minus 6.4 molar. So it is very small, but still it is greater than 0. Still it is greater than 0. So that's why total acidity is greater than 0. So remember, so these are some, I think I have like so alkalinity can be like you can find alkalinity of the system by titration also. Generally for titration we use 0.01 normal HCl or 0.02 normal H2CO3, and we use phenolphthalein indicator and methyl orange indicator, and then we calculate the amount of volume consumed to change the point. So if you add the phenolphthalein indicator, if the pH is greater than 8.3, your system will be pink in color. But as soon as you start either any of the acid and the pH goes below 8.3, it will be colorless. Again you will add methyl orange, and if the color, if the pH is 4 above 4.5, it will be yellow in color, and below 4.5 it will be orange in color. I hope these are clear. And there is direct formula also. The direct formula of total alkalinity is minus H plus plus H plus OH minus plus HCO3 minus plus twice CO3 minus, and this will be in mil equivalent per liter. Remember the unit. Whatever the concentration has been given to you, first you have to convert into equivalent per liter. This is very important. So if you are applying direct formula, you have to be cautious that you have to convert into equivalent per liter. Okay, and there is one more direct formula, that if you have been, so like this is not more direct formula. So generally alkalinity is always reported in milligram per liter as CaCO3. Can anyone say what is the equivalent weight of CaCO3? Equivalent weight of CaCO3? What is the equivalent weight of CaCO3 in milligram per liter? Equivalent weight, I have written equivalent weight of CaCO3. Molar mass by 2. What is the molar mass of CaCO3? See, like, don't answer like this molar mass by 2. If someone is asking you the exact thing, try to answer like, I'm not saying anything, but this, don't make this thing as a habit. If you are in an interview and someone will ask you what is the equivalent weight of CaCO3, and you say that molar mass divided by 2, that will just give bad impression. Try to be as much as precise you can. So write the answer. Molar mass of CaCO3. I think everyone knows the molar mass of CaCO3. Correct. It will be 50. So like, and also try to write with unit. What 50? Gram per liter, gram equivalent per liter, yeah, milligram equivalent per liter. What? This 50 is what? What is the unit of this 50? I hope everyone is also following the what he has written is correct, 50. So I am asking about the unit. What is the unit? What is the unit of this 50? Again, gram per mole. Yeah, correct. You have written it very exactly. Equivalent weight. No, it won't be milligram per liter. It will be gram equivalent per liter. Again, so if you have converted into equivalent weight, you cannot write unit as milligram per liter. It, first of all, it won't be milligram per liter. It will be gram equivalent per liter. You will write equivalent. You can write in anything, eq gram per liter. Yeah, this is correct. And like you don't have to write this liter right now because I'm just asking the molecular. Yes, correct. This is the perfect. Amitabh Mukherjee has written the correct gram equivalent. Right, did you Rajiv? You were writing 50. I hope this is clear to you. Gram equivalent gram. You can write anything that will work. Sorry, gram equivalent. What I mean, like Amitabh and this Rajiv. Then I hope this Ravi Kumar, you have also right. You have written 50 as correct, but you don't. No, shall I write say 50 milligram per liter as no 50 milligram per liter as CSU3. That is that will be like you will be converting some into milli. No, you cannot say 50 milligram per liter as CSU3. This is like this does not make any sense. What is 50? So if you are saying 50 milligram alkalinity is 50 milligram per liter SCO, that is different thing. But if someone is asking you equivalent weight of CO3, you will say 50 equivalent, gram equivalent, gram equivalent. Remember this thing. I hope this is clear to you. So you can like if you are so generally this is if someone is preparing for gate examination or anything, generally this question is asked. So you have to you will be given so one very random question is like they will list out many cations and anions. They will ask you to find out the alkalinity. So you have to always consider OH minus, bicarbonate and carbonate. Whatever unit has been given to you, you have to divide by equivalent weight of that thing, and then you have to multiply it by equivalent weight of. Remember here, if the concentration is milligram per liter, so you have to put your equivalent weight in. Like you have to make sure that you are putting everything in a correct unit. Unit should be correct. For more like solving these, refer to some previous year gate question, particularly of environment. You will find this thing. Very good question related to this topic. I hope this is clear to you. Any doubt in it? So the correct answer was D, and already I have discussed about the acidity. Acidity is referred to property of substance that can donate H plus to the waste. The strength of the acid often measured by ability to blah blah. This is I think this is acidity is very simple. Okay na, and remember alkalinity. Like I don't think you will find having if very at very low pH the alkalinity will be zero. Okay na, but you will because at uh, it will be near to zero. It cannot be zero. Okay na, just remember this thing. But somehow if you like make system very acidic, then all the OH minus will go, all this thing will go, then you will have alkalinity zero. Again I don't know what is happening to my animation. Just wait for 1 minute. Just wait for 1 minute. Hmm. At the given option, the lowest BOD of the having for so if the COD is 450, everyone know BOD. What is BOD? Full form of BOD. Anyone?
Biochemical oxygen demand.
Yeah, good. So now there is a question that what will be the likeliest BOD of the wastewater having 450 milligram per liter COD? Yeah, biochemical oxygen demand. Correct. Okay, so the correct answer is B. But remember, this like I am discussing this question because I was asked to discuss, but I found this question wrong. So when I was like when I was doing my course at IIT Kanpur, so we were asked one question. Everyone was asked this question: can BOD be higher than COD? Maximum BOD is than COD. Generally, BOD value is less than COD. We can say three times. This is correct. Sometime equals. When it will be equal? Just I'm searching one question that was asked to me during my master. Hmm. So when there is no non-biodegradable matter, yeah, when it contains biodegradable organic parts only. BOD is only organic, but COD organic plus, yeah. In that case, it will be like what you guys are saying is correct. But there was one I don't know. It's like I don't remember. Maybe next time I will search it out. But there is one condition where there will be your COD can be BOD can be no, BOD cannot be greater than COD. Like I don't remember the question. I'm not able. I'm not getting that question. But I think I was asking the. We were asking the examination. So coming to this question, this COD we all know that yes, the correct answer is like 270 only. B. The COD is the measure of oxygen required to chemically oxidize both organic and inorganic substance of sample water. It is determined by potassium dichromate. COD provide estimate. So you can everyone know what is COD. So the correct answer is BOD is generally a fraction of COD. In most cases, BOD is significantly lower than COD because COD measures the total amount of oxygen, while BOD measures only oxygen demand from the biodegradable material. So it is generally 270 like it will be some fraction. So just you can calculate. So the ratio which is given BOD to COD, that is given 270 divided by 2. So generally it is said that so it's like 60% will be BOD and remaining will be nothing. Okay, na? So that's why the total COD will be more than BOD, and BOD will be 60% of COD. So that's why the correct answer will be. Any doubt in how sewage sometimes contain high BOD, less COD due to full organic. So it's like, I don't know about this statement. I have no idea. But you can think. Just think like search. Next time you can remind me that I will go and search in which case BOD is higher than COD. But do your own research and try to find out like in which cases this one will be higher than BOD will be higher than COD. Okay. So match the following type with improper wastewater management with the related examples. Effect of improper wastewater level. What can lead to the what? Okay, na. So organic pollutants will lead to what? Emerging contaminants will lead to what? What is the effect of nutrient? Okay, na. If anyone have any doubt in any discussion, you can just ask me. D. D. Yeah, D is the correct answer. Organic pollutant will lead to BOD, COD. Emerging pollutant will lead to are antibiotic and pesticide, and these are nutrients are orthophosphate and nitrate. Yeah, correct. No, like this refer to the substance that are primarily carbon based and can be measured POD biochemical oxygen demand. COD chemical, they are indicative of amount of organic matter. Emerging, they are recently organized pollutant and are not commonly monitored or regulated, but can have significant effect. Example include, and we have the nutrients. So remember the effect of eutrophication. Whenever this nutrient term comes, you should come up with the term nutrification. This substance can lead to the nutrification in water bodies, which can result excessive growth of algae and other aquatic plants. Key nutrients are phosphate. So the correct answer is D, that is ACB. I hope this was very simple question. Everyone, I think everyone answered it. So I will be moving forward. Coming to the question number 8. BOD 5. This 5 will go. Value of two wastewater A and B are measured at 80 milligram per liter and 220 milligram per liter. This signifies that what will be answer it. Very easy question. Few minutes ago you have answered. We have discussion about this thing. Uh, Amount of organic and inorganic. Sample A have lesser biodegradable than load than B. Sample A has higher. Sample B has less quantity of biomass. Blah blah blah. Yes, A. I am getting everyone. I think everyone is agreeing to A. So yes, the correct answer is A. BOD5 is the measure the amount of oxygen consumed by microorganisms to decompose organic matter. The higher the BOD indicates the higher load of biodegradable organic matter. Given that it is 80 milligrams, so obviously this will have higher organic matter. Sorry, lesser organic matter, and this will have higher organic matter. So sample A have lesser biodegradable organic matter load than sample B. Very simple question. Okay. Any doubt in it? I don't think there should be any doubt in it. Question number 9. Identify the correct statement regarding the emerging contaminant or contaminant emerging concern. Statement 1 is emerging contaminants are generally bioaccumulative but are non-persistent and have lesser toxicity. Emerging contaminants become relatively easily identifiable with new techniques for chemical identification and separation. Which are correct and incorrect? First is bioaccumulative, then second one is like easily identifiable. B. What about other those who are in the session, please answer it. Both are incorrect. Rahul Kumar is saying both are incorrect. Both are incorrect. I don't think so. Both are incorrect. Read the question again. So this is directly from your like session. Emerging contaminants, also known as CEC, are substances that are increasingly being recognized as a potential environment and health hazardous. Are not regularly studied. These are pharmaceutical waste such as antibiotics, hormones. Then we have endocrine disruptors, chemicals that interfere with hormonal system, including some pesticide and industrial chemicals. nanoparticles are there, then industrial chemicals are there, such, and these all are bioaccumulative. So if you, what will happen that if you use some this kind of pesticide or something, so that will be taken up by plants, so that plant will contain, if you eat that plant it will go into, so if we eat that plant it will come into our body and it will remain in our body. If we keep consuming those things it will be remain. So like you can a statement 2 is correct, technology statement 2 is correct. What was the statement 2? A statement 2 is not correct, so you, I don't understand, you said b means a statement. Pharma API contamination not, just let me go one by one. Technology gas gas chromatography is to identify emerging contaminants. So like I don't know. See, this is like I don't know from where you are studying. Like we are talking about water samples. Why you are talking about gas chromatography? Gas chromatography is used to like analyze the pollutant, yeah, contaminant in gas sample. You have water. We have many instruments that is used to analyze water echo sample. Why we are going for the gas chromatography? Fi pharma. See, the correct answer is two, that the statement 2 is correct while the statement 1 is incorrect. So these are very toxic. Just remember, it is saying less toxic. No, it is very toxic. And API contamination non easily identified. So see, there might be like few things are cannot be like in India still we are not able to identify, quantify PFAS and everything. It does not mean that it's like if you have technology you can easily identify. Okay, na. So like there are many chemicals like antibiotics, everything can be easily. We have many instrument. We have ICP-MS, GC-MS, then we have LC-MS. So these are used to identify. These are like most, I think people like antibiotic and everything, people use these things, like it's like I have never identified use this emerging contaminant, I have not worked it. So I work on the like inorganic contaminants like arsenic, fluoride. So for that I use ICPMS. So I have an idea about ICPMS. There are some organic compound in our sample. For that we use LCMS. So like technology is there. Okay, na. So it's like we don't have that technology. That is another case. But technology are there to identify. I think currently we have also many technology to identify everything. Okay, na. So this at various levels of bio they can, so these are bioaccumulative. Okay, na. See, this statement was correct generally. This at till point it was correct, that is generally bioaccumulative, but are non, no, it's very persistent. It will like you have heard of forever chemical PFAS, and it's very toxic also. Okay, na. So saying this thing is not correct. Liquid chromatography. Yeah, people use liquid LCMS. That I told you too. LCMS liquid. There are many things. ICPMS, LCMS, LCMS, GCMS. Sorry, GCMS. We have to like this gas chromatography. HPLC. So there are many things. We are not here to discuss about. So HARM. What is HARM? I also don't know what HRAM. Let me search. I have not used HRAM. HRAM. What is HRAM? HRMS is there. HRMS is there. I don't know. HRAM is something called HRM. High resolution mass spectrometer. So that is different. That is not HRAM. That is HRMS. That is HRMS. I don't know. Huh? There is nothing called HRAM. Emerging contaminants are identified through advanced analytical techniques, relieving their presence in environment, water, soil, air. Its impact become better understood. Regulatory frameworks may be evolved to address these concerns. Okay. So the yes, the B is the statement two is the correct, while the statement is one is correct. Okay, now so these are some of the things which I have written down. You can take a note of that. But we will be. I think we have. I hope you have understood. We have several instruments to identify those things. Again, just 1 minute. Try to everyone take 1 minute or 2 minutes and try to self solve it. The wastewater contain in 180 milligram acetate. Contribution of acetic acid. Theoretical COD of the water wastewater is. What will be the theoretical? Just answer it very quickly. It's 58. Try to answer it by 8 p.m. Anyone? D. Check your calculation. I will suggest check your calculation. 360. Check your means like check your calculation. 360 is not the correct answer. See, it is milligram per liter, so you just cannot just multiply it. Again, see, this is the problem. I told you last time also when someone asks you, try to answer it in exact way. Last time also you answer molar mass by 2. This is take your pen. I have given you 1 minute time. So like you can like solve it. What you are saying is also correct. 1 mole of acetate consumed 2 O2, that is 60 milligram. Take your copy, pen, paper. This is MCQ question. So just and write the answer. This is my answer. See, I have got one answer, that is 192 milligram per liter. One question to everyone. What is the unit of COD? Is this everywhere? Last time, like I forget to discuss. At that time, also it was written as something milligram per liter. So, each milligram per liter is generally used as unit of COD. Can anyone say milligram per liter? Generally, this is not the correct unit of COD. Or you have to always mention it as milligram per liter as O2. Everywhere it should be O2. And in the here it is correct. So this is acetic acid concentration. 180 milligram per liter is correct. But when we are talking about COD and BOD or DO, you have to write milligram per liter as. So at so here there was one question. What is the COD? Blah blah blah. Huh. So here also it should be 450 milligram per liter as O2. 0 milligram per liter as O2, 270 milligram per liter as O2, 450 milligram. You will like understood why I am saying this O2. When I will discuss the solution of this question, then you will get to know why this is written. And also, if you look at the derivation, how COD is determined, how DO is determined, you will understand. Yeah, because we are like asking, we are thinking that how much oxygen is getting consumed. So that's why. Others, those who are here, did you understand what I said? Amitav, Anusri, Lakshmikant, Rahul, Rajiv Ranjan, Ravi Kumar. I hope you have understood what I was saying. That always you should write milligram per liter as O2. Okay, so this is the solution. So here we can see that acidic 1 mole of acetic acid is get consuming 2 mole of O2. So we know that number of moles is equal to given weight divided by molar mass. One thing you should see that I am writing unit everywhere, because when you will be like, I don't know how many miss what you guys are doing, currently you are in industrial or you are in BTech, you are MTech. But when you will go for the higher study, this thing you should make yourself very familiar with the unit. Always that unit. Given weight milligram in the gram. So that is at 180 milligram per liter. What is the molar mass of acetate? One oxygen, one two carbon, two oxygen, three hydrogen. It will come out to be 60. So this is 3 millimolar. Remember, milligram gram get cancelled. Gram per liter, mole per liter is mole, millimole. Okay, sorry, is mole per liter. We also like mole per liter is also known as molarity. So that's why I have written 3 millimole. Milligram per liter is converted into millimole, 3 mole. How many oxygen is getting consumed? 2 mole. So how many oxygen, what will the mole of oxygen? That will be 3 into 2, that is 6 millimolar. And we know that mass of oxygen is 32. That's why 6 into 32, that it will be 192. Again, I should write theoretical COD as 180 milligram per liter as O2. Remember, as O2. Okay, you should keep this thing. So this will be the final answer. When you are writing theoretical paper, make sure that you are not making this mistake. So this will be final answer 192 million. So correct those who were saying D. Those who were saying D, I hope you. I think one person was saying D. 192. Ravi Kumar, you have said it. You have solved it really. It will not. Like good. One again. You should write unit. So like why unit? I'm saying like there is one professor here who used to, whenever he will give us question, there will be some step marking. So if your final answer is correct and somehow you have not written unit, he will just detect half mark. I mean like 50% of your marks just because you have not written unit. So suppose the question was of 2 marks, you will get, even if your answer is correct, he will just give you 1 mark. So have this habit of writing unit. Again, there is one another question. Question number 10. 5 ml of BOD sample by diluted with aerated distilled water made up to 300 ml in the BOD bottle. The initial DO was measured as 8.2 milligram, which dropped to 1.8 milligram in 5 days. BOD 5 of the sample is. it is like numerical question. So just see, if you have to give, you have to discuss anything, you can write in the box, but I will like it is 20 0, like it's 8 6. I will wait till 8 8 2, you have 2 minutes of time. So there was 5 ml of wastewater that was diluted to 300 ml. Then initial BOD was measured. It was dissolved oxygen was measured. It was 8.2 milligram, which dropped to 1.8 milligram per liter in 5 days. What is the BOD 5? 384 milligram per liter. Okay. Yes, correct. Milligram per liter as O2. You have to always report answer as milligram per liter as. And also you must be noticing one more thing, that wherever there is a L in throughout the presentation, it is capital L, not a small l, because liter is always written as capital L. Go to my previous, like if you go to the previous thing, everywhere you will see this, notice the capital L, capital L, capital L, capital L, never a small l. So in milligram per liter, the liter is always capital. So these are very few things that, like, in scientific world these people see this thing. Okay, now how you are writing your liter, how you are writing your millimolar or molar. So the correct way to write will be milligram per liter as O2. I hope this is clear to you. I'm talking about the unit. Yes, standard symbol and unit must be written. Like I don't know how many of you have noticed in your book also, where you will see milligram per liter, L will be always capital. Just go miss, if you have gone, if you have noticed in this thing, then it is good. But you can go and check, you can check any book, whether it is NCRT or any book, you will see L as capital. Wherever they have written milligram per liter. If you have to just write liter, you can write liter in any way. I hope you have understood what I was trying to say. 384. I have got one answer. 384. What about other? 9 people are there here. Anyone? 384. Yeah. So, like, before going to the final answer, I will be just discussing some theoretical thing. So, we all know that the BOD is biochemical oxygen demand, and it is a wastewater parameter. Wastewater parameter. Remember, there is one very tricky question is asked, that what is the BOD value in drinking water? Ah, 884, not 884. I think you have done minus 6.4. Sorry, 384. Yeah. Determination involve measurement of diesel oxygen by macro unit biochemical oxidation is slow process and theoretically takes infinite time to complete. Within 20 period time, the oxidation is about 99% and 5 period. So like there is generally question, within 20-day period oxidation is about 99 to 95% complete, and in 5 day period BOD oxidation is 60 to 70% complete. So generally, hello again, I think hope you are able to see my screen. So do you, hello, am I audible? Hello. Okay. So DO is determined by agile modification method. The DO, normal DO of the water is 8 milligram per liter. So the BOD test, this is known as BOD tube. Okay, now that has a fixed volume of 300 ml. BOD is bottle is used in the experiment which has a fixed volume of 300 ml. during experiment sample is diluted as per oxygen. So see, remember, like how much you how much so how to explain this thing. So what I was saying, that what is the standard term, what is the standard day and term time to during the current, this same 5, so 5 day everywhere, 5 day 20 degrees Celsius. This is the standard method people are still using. If you want faster result, you can go for 3 days also. But currently this thing, 5 days 20 degrees Celsius is considered. So I will explain this term when I will show you the formula. Okay na? So see, uh, just 1 minute. See, so if you like, BOD is defined as BOD BOD is defined as DO initial, minus DO final. Okay na? DO final after 5 days. So remember one thing, that if your water is pure, then it will have 8 milligram per liter as its DO. Okay na? But if some organic component will there, this will start to decrease. Okay, this will start to decrease. So as organic matter is coming, so this BO, as per my industrial revolution, as per my the England, yeah, this Royal Chemical Society has done this thing. So to manage everything, we have this Royal chemistry or something, I don't know, in England only. So they have fixed this thing, that we will be finding DU after 5. So it's like there is a specific region, and the region is this thing. Okay na? So if you see the curve, how this oxidation is covering, it is like this thing. Okay na? So till this time, it will be carbonious oxygen demand, carbonous oxygen demand, nitrogenous oxygen demand. So till 5 days, it's like all the carbon which is there in our system will get consumed. So that is representative of COD. Now if you have high amount of nitrogen, that will be other case. So this is the basic region. Like what you are saying is that is true, that in doing in England in Royal Chemical Society, they have done this thing, that we will be measuring BOD after 5 days at 20 degrees Celsius. But why, you should know why. This is the region. Like you can go through the video lecture in, and you can, I think sir has explained this thing, why we take 5 days only, because this, due to this curve. Okay na? So till 50, till 5 days, it will be 60 to 70%. So currently this has not changed. People have modified it for 3 days, if but that is okay. Huh. So what I was saying, that why you have to dilute it. So what will happen, that if the organic matter starts to come, so what will happen, that initial DO will be less than, it will be around 6.3 to maybe 3 to 4. Okay, maybe 3 to 4. So like, so and the final DO will be after 5 days, it will be around 0. So you cannot report your BOD as 3, because you know that your sample contain high amount of organic matter, and that you can know by the chemical oxygen demand. Okay na? So to find out like how much you have to dilute, first you have to do chemical oxygen demand. And remember, there is one table also, table where it is say that what it should be the value of chemical oxygen demand. If the value is this much, you have to dilute this much. So that's why, when if the your COD is very high, You have to dilute it accordingly. Okay, I hope this is. Oh, I hope you have understood it. I will refer one after this discussion. I will refer one book also. You can go there and you can read it. And the dilution factor is given by total factor by volume of sample. Okay, na. Initial DO will assume by as I no. Wrinkle method is something different. I'm not able to remember wrinkle method, but I think this is different. Just 1 minute. It's same. I mean, like it's like wrinkle. The method is agile wrinkle method. Yeah, you are asking or you are saying this thing. Just let me know. Yeah, no. Both are like modified. Is like wrinkle was the scientist who like said like generally we have nitrate in this. It's like I'm not remembering the exact mechanism, but he had modified by adding azide. So generally, in initial unmodified method, there was no azide was not added, but he added azide, so that's why it is known as modified azide method. So that is yeah same wrinkler method. I hope. So the initial DO is measured by azide modification method for 5 days. Sample is incubated at 5 degree at 20 degrees Celsius. And after 5 days along with the blank do for the blank sample we also measured. So like you will be diluting your sample with one water that is free from any organic matter, so that will be considered as a blank sample. Okay, the blank sample is water used for dilution, sometimes referred as dilution water. After 5 year experiment you have the following experimental data. Actually Hmm. So after experiment, you have initial DO value, that is DI, DO of the sample after 5 days, that is DO5, initial of the blank, that is DBOI, DO of the blank sample after 5 days, that is DBO, and you have dilution factor. So the if you have to find out the BOD in the form of milligram per liter as O2, your this will be your final equation that you have to use. DO initial minus DO final, that is DO after 5 days, minus DO of the initial blank minus DO of the blank after 5 days into dilution factor. Did everyone get this formula? Wrinkle method, nitride influence, azide, no nitride. No, so I think these are some of the basic things that you have to remember. But I was coming to this final thing. Yes. So for our question, so initial DO was 8.5. Sorry, 8.2. DO final was, and if the blank data is not given, you have to assume for the blank the DO is 0, and the D final is 3. That is sorry. Dilution factor will be total volume, that is 300 ml. How much wastewater we have added, 5 ml. So dilution factor will be 60. So if you put all the value, 8.2 minus 1.8 minus 0 into 60, and it will come out to be 384 milligram per liter as O2. Again see, I have written capital H and as O2. I hope this one is clear to everyone. So right now I have two things. Just tell me. So I have like so I will be going through some. We have gone through the question. So till now, anyone have any doubt? BOD, COD. So I have like many things right now, but I will directly go into the question answer. Okay, now. Question answer. Question number 12. So here like I will be discussing also. I think everyone is. So this is related to next question is related to MPN and everything. Okay, now. So like I will be going in very fast manner. If you have anyone have any question, you can ask me. Like you can stop me in between. And I think if you have gone through the lectures, I think you will have idea of this. So microbiology is the study of microscopic organisms such as bacteria, virus, pathogens. So like one thing which we have to make sure that our water does not contain any waterborne pathogens because it can cause any many diseases and so water may contain many different type of pathogen. Water sample must be tested presence of which is difficult. So like we know that water content can contain bacteria, viruses, archaea, many things. We cannot just go and measure each and everything. So for that we have identified something known as indicator organism. So that is coliform bacteria. So if that is present in your sample, we will say that it contains some kind of microbes, yeah, pathogens that can cause waterborne disease. So somehow, if you just see the presence of coliform bacteria, you can say that yes, your water is pathogen free or not. Okay, na. So like pathogens, coliform bacteria are present in the feces and all form medical animals and humans. The number of coliform bacteria in the feces in order to influence magnitude higher than pathogen bacteria. However, coliform bacteria are themselves generally not pathogenic. However, their presence in drinking water or in wastewater. Wastewater will contain some could be present. It is relatively easy and expensive to test for coliform bacteria. So if coliform bacteria are present in water sample, the water may contain, remember, it does not signify that it will definitely contain pathogens. It may contain pathogens and hence is likely unsafe for drinking purpose without disinfection or for any use. Water is not likely to contain pathogens. So how this is generally done? So like these are some of the basic things about coliforms. So if you want, you can take pictures and you can read about it. But I am coming to how testing is done. So there is often bacterial coliform of the water is highly enough to require dilution before enumeration standard. Water sample are diluted by serial dilution technique, which is illustrated in the following figure. So we will take our original sample, and first we will in the contain 10 ml of undiluted sample. 1 ml of sample is transferred into the second tube, which is already contain 9 ml of sterilized water, that is uncontaminated water free from any bacteria. This procedure is followed to obtain larger and larger dilution. So if you will keep going on, you will find out 10 key power minus 1, 10 key power minus 2, 10 key power minus 3, 10 key power minus 4, 10 key power minus 5, and so on. Okay, 5 time, yeah, 5 time dilution. So remember from here, so like I'm not going to discuss about this. So this is like, so this MPN test is like finding probability. It does not tell about how many number, it just tell you a like probability. Yes, this much is the probability that there will be some kind of bacteria. Okay, na. So so like they let so if you have taken one sample, there might be a number of organism in the B volume. So you have taken some B volume, so consider that there is a n number of bacteria. Therefore the average number of organism per ml of sample is n by V, and they have said it as a lambda. If it's like, I hope you are, I have written it in very simple way, like so that you can understood. Note that this does not mean that every 1 ml of liquid from the original VML sample must contain. So, like you have this container jar, this much of jar. If you have taken some XML, okay, na XML, so it will contain some n number of bacteria, okay, na. If you take another volume, it won't contain n, it might contain any other thing. Okay now, this is what is written. In fact, any particular of n m liquid may contain zero, or if you take like it can contain anything. So the probability, probability that if you take any 1 ml of a liquid, and like the probability that a 1 ml of a liquid will have x organism is given by this distribution, that is Poisson distribution, and that is lambda ki power x into exponential x divided by x factorial. I hope this is this is simple, the simple probability that we do in our MPN test. So there are many methods to find to find MPN. I will be going through that also, but currently remember that this is also one, like if someone asks you that how mathematically we can find the MPN, you have to say, you have to start by saying that if I take x number of aliquot, it cannot contain n number of sample. Different aliquot will contain different number of sample. So what will the probability that 1 ml of sample will contain x organism, that is given by, so when there will be no organism means x will be 0. So this will be come out to be probability that x is equal to 0, it will be given by exponential 1 minus exponential ki power lambda. And we know that probability, sum of probability is 1. So probability that any sample will contain some organism will be given by 1 minus lambda ki power x, sorry, exponential minus x. If you are not understanding it, no problem, you can use another method. Okay na. So another method is like testing method. Okay na. So so this is this is your tube, and this is small is known as Durham tube. Remember Durham tube. Okay na. So here we use one type of broth, that is L'Oreal trapdoor broth. We put it, we keep our sample here, and that we add 1 ml of sample to the test tube, put the cap and let it incubate for 24 hours. If the media turns cloudy and gas bubble are seen in the air, then test is positive. So this is what, remember, this is generally asked, what is the, which tube we generally use in our MPN tube. So this is known as Durham tube. Durham tube. I hope this is. So if you see the bubble, means there is some kind of fermentation is going on. Some microbes are present, and some microbes are present. Sorry, microbes are present, and it contains some kind of coliform. Okay, now. So, uh, hmm. So again, I'm going to back through. If you're not understanding, just let me know. I will move forward to the normal topic. Are you understanding what I'm saying? like I have a perform experiment. I came out to know that uh, uh, there are some tubes which is giving positive. We understood. What about other? Amita, Amitav, Anusri, Lakshmikant, are you understanding what I'm saying? Rajiv Ranjan, Ravi Kumar. Okay, so I hope you can not math but theory understood, huh? So see, huh? So I will show you how it is. So there is simple method to also find, but that simple method is also coming from this method only. So you perform experiment. So after you have done serial dilution first. You know that you have to do serial dilution. You did serial dilution, then you know the mathematics. What is mathematics? That there is no sample. The the probab MPN, that this lambda will be expressed in e ki power minus lambda. And if there is organism, means if the test is, if there is some organism, it will be 1 minus exp ki power lambda. Okay na. Your aim is to find lambda, that is the probability. Okay. So you done this thing, you have added everything, so after experiment, you found out that you have taken three tube, you have taken tube, three dilution, that is 1 ki power 1, 1 ki power 10, and 1 ki power 100. in 1 key power 1, 1 ratio 1, all three tube give, like you see the bubble in every tube. In dilution 1 is to 10, you see the bubble in only one tube, and in third you see only one, in no one show any gas, only all were negative. Here one positive, here all three positive. So if you if you look into the formula, what was the formula saying? What you were saying, that is not mpn, that 310 is not mpn. So see, like that is their thing. I'm explaining something that might be useful in the future if you are like doing some kind of research or studying in the deep. So here what I say that the distribution which I showed to you, this distribution what does say, if there is bacteria it will be 1 minus exponential ki power minus lambda, and if there is no bacteria it will be exponential minus lambda. So here just look into this thing. So here in all three tube we have seen that there is some kind of bacteria, so it will be expressed in 1 minus e ki power minus lambda. And we know that when we have, like this is the probability thing, that if you have to find the probability of very large number, all the probability will multiply. For this case there is only one positive, means 1 minus ex, like here I have taken the dilution is 10 ki power minus 1, so that is 0.1. But for two cases it was negative, that is x is equal to 0, so that is exp 0.1 lambda x square. And for third case, that is lambda, it is 10 ki power minus 2, and there is no bacteria in all three cases, though it will be exponential 0.01 lambda ki power 3. So like to find the lambda per ml you have to solve it. So there is two way, either you can find the derivative, keep it as a 0, and you can find a lambda value. The second method is that you can plot it on your excel sheet. The MPN value for the above sample defined, for which the MPN value maximum, the solution can be obtained analytically by plotting the P lambda versus lambda using a spreadsheet and observing the value of lambda corresponding to the maximum value of P lambda, like this thing. Additionally, MPN can be also for, so this is Thomas formula. Number of positive tubes in, so this is generally used. So either you can use math or you can use Thomas formula. Thomas formula is number of positive tubes into 100 divided by ml of sample in the negative tubes into ml sample in all tubes. Okay. So for our case, like this is another example. So this example I have taken for my experiment. Okay, na. So I have performed one experiment. In I have seen that for some, so like for when sample size was 10 ml, in there was two so I have taken total three tubes. Sorry, so I have three samples, sample A, sample B, sample C. So for sample A I have total taken three tubes, out of which two were positive, in here one were positive, and here 0 point in 0.1 two were positive. So if I do this thing, plus plus g minus plus minus minus plus plus minus minus, for sample A this thing 2 1 2, so it was plus plus minus plus minus minus. So I have written this formula in my formula. Okay, now my aim was to find lambda. So if you solve it you won't able to find it, so what I did, I plotted on the graph, and here we can see that at 2.7 I was getting the maximum probability p lambda. So our lambda value will be 0.27 per ml. So generally MPN is reported in MPN per 100 ml, so that would come out to be 27. So this was mathematical method. Second method was that you have to use Thomas form, or you can use table also. If you can use table also. So for table what we have 2 1 2. See, I don't know, either you are saying. I hope others who are like others who are here able to explain this. are able to understand it. Okay, so like here you have to use, now you use this table. So I have that table. I hope I am able to find that table, week 3 mpn table, huh? Hmm. So here you can see, I think we have table. So our, what was the our for our case, what was the code? 212. So here if you 212, if you go for 212, 212, where is 212? 212, huh, this one is 212. So mpn is not it's erased here, so somehow I am not able to copy it, but its value will be 27. So I am not able to get it. Okay na. Do I have another table? No, no, I don't have another table. So but if you look into the table, you will get this as 27. So from that table and from this mathematical, you will be getting same mpn value. Okay na. So and there was one formula also, number of positive tubes. So here you will also multiply, so you will be getting this mpn as 249. So so the difference is here, because I have used here 3 tubes, but here I have applied the formula for 5 tubes. So that's why it is, but if you do the calculation, it will be coming around 27 only. Did you understand anything what I said right now? Anyone? I'm asking other. So what I was saying, that either you can use method. So don't depend upon the formula. Like, try to know from where does this mpn table has come. What I was basically saying is that how this mpn table was made. Ouch. Just 1 minute. Again, there is some problem with. So I think this PDF will be provided to you. If you want to take that, if you want to understand these things, you can go back. You can look into this formula. You can go to the recording of this session, or you can contact me. I will provide you. So if you have understood it, you don't like. I think you not calculation. So see, either you have to use Thomas formula, this formula, number of positive tubes into 100 divided by, generally if you are preparing for any gate examination or anything, this is sufficient. Or you can use this table, which I said, this table, mpn table. So here, like, you have to identify how many samples are there, how many positive negative samples are there. You have to generate code, you have to see here. Okay, you can do anything. So for example, for the next question we have this thing. In mpn test, 10 ml, 1 ml and 0.1 ml of wastewater was inoculated in 5 replica in nutrient broth. The result were 5 to 0 positive respectively after 48 hours. mpn use 5 replicates. Here in the question itself we have given that use table. Okay na. So first you have to process what is the question. So 10 ml, 5 were positive, 1 ml, 2 were positive, in 0 ml, 0.1 ml. So the code is 520. So you have to go to that table. I will be going to that table, 520, 520, 520, 520, 520. The mpn is 49 ml, 49 coliforms per 100 ml. So your answer will be 49. So this is what I have written. Now one question related to I think if I think I have like try to solve this question. Okay, now you have to find TSS, total suspended. So this was all related to microbiology. Any doubt in this microbiology thing? What about other Anusri Singh, Rahul, Ravi Kumar sir, Ravi Kumar Mani. Anyone have any doubt till in this microbiology thing? No, then I will move forward. So this is one simple question. Everyone, take your time. It's 42, 8:42. I will wait till 8:45. I need one answer. You don't have to write explanation and everything. Just take your pen, paper, and solve it. And give me what will be the value of TSS, total suspended solid. So I will read out the 100 ml wastewater sample was filtered using one filter paper, that is glass filter. Okay, GFS paper of filter paper of weight itna, the filter collected in a silica cube weighed itna gram. Both crucible and filter paper were dried for 24 hours at 40 degrees Celsius. Post drying, the weight of the filter paper and the crucible measure was at this much and this much gram per liter. Therefore, both crucible and filter paper were kept in the muffle furnace for 20 minutes at 550 degrees Celsius. Post ignition, the weight of filter paper and the crucible was measured as 1.82 gram per liter. Based on the following data, you have to you can take a picture because there are three questions related to this 13, 14, 15. So I will request everyone take the picture of this question paper because you have to use in the question number 13 also 14 also. So this is question number 13. You have to find TSS, what is the total suspended solid. So you have to, if you want to understand in a better way, I'm just telling you, I'm giving you an example. So like there crucible was there, filter paper was kept here, scan. So like you can just simply wastewater was taken, it was filtered using filter paper. The like what do the filtrate was collected in the crucible having weight na, and the filtrate for the filtrate and filter, what are those two things, whatever some solids were retained here, something. So it has some weight that are given to you. So you have to find total suspended solid, and the initial volume was 100 ml. It's 46. Anyone with any answer? Anyone with any answer? No answer. So see, remember this: if you are filtering something, suspended particle will be attached to this filter, and dissolved particle will go into the filtrate that is collected in your crucible. Okay. So remember, whatever the calculation that you will do on this filter paper, uh, on this filter paper will give you TSS. Okay, and whatever calculation that you will do on this crucible will give you dissolved solid. I hope this is clear to you. So for my 13, that is TSS, the mass of the bulk filter is 1.7 gram. Mass of the crucible is this much. Mass of the after drying, the mass of filter paper has become 1.92 gram, and the mass of crucible has become 29.92. After 550 degree, the mass of filter paper is 1.8 gram. So clearly, currently we are trying to find the suspended solid. So whatever has been collected on the filter paper. Okay. So generally, when the filter paper is subjected to 1054 or 5 degrees Celsius for 24 hour, whatever weight we get, we will getting it corresponding to our suspended solid. So what was after 24 hour, after dry oven, what was the weight? 1.924. What was the dry blank filter paper? It was 1.70. So what is the total volume? 100 ml. So initial final minus initial weight divided by 100 ml. Now remember, I have converted gram into milligram. Means I have multiplied it by 1000. Okay, and milligram has been converted into liter. So that is 10 ki power minus 3. Okay. So if you put all the value, if you do the calculation, you will get the value as 1740 milligram per liter. These are very simple question. Remember, you have to like very attentive. I mean, like you don't have attentive, not you don't you can you should know where which will lead to TSS, which will lead to TDS. Okay, because the next question we have question number 14. Question number 14. Where is the question number 13? Oh, this was question number 13. So question number unit conversion. Yeah, you have to convert because you have to report your answer in milligram per liter. The next question is the volatile suspended solid. Okay, now again the suspended. They are asking about the suspended solid unit conversion. Okay, just 1 minute. Just 1 minute. Can you see one screen I'm sharing on mobile? Everyone, can you see my mobile? I think I'm sharing via my mobile. Eh, let me know. You are not able to see my mobile screen. Mobile. I think I'm sharing via my mobile. I'm like, because if I have to. Yes. Anyone saying no? Ravi Kumar, can you see my? Yeah. Just 1 minute. We are on slide. This thing. Huh. So here I'm writing. I hope you can see my. So what I was saying that. So this is gram. So if you like, this is. Hmm. Hmm. So here you. Hmm. So here we have gram per ml. Okay now. So now gram has to be converted into milligram. So it will be 1,000 milligram. Okay, and this milligram will be converted into liter. So it will be 10 ki power minus 3 liter. Okay, I hope like just 1 minute. So overall, so I what I have done that I have converted gram into milligram. I think this is clear to you. Similarly, milligram I have converted into ml, sorry, liter, that is 10 ki power minus 3 liter. So over will be, so remember the final thing which we have to report is in milligram per liter. So and so now whatever we have left, what we have left with 1.924 minus 1.750. So if you go to the calculator, what we have 1.9, oh, sorry, 1.924. So I think you won't be able to see my calculator. So 1.924 minus 1.750 divided by 100 into 10 so see, so I had 1.9, I think hope you can see my this calculator. 1.924 minus 1.750 became out to be 0.174. divided by 100, that is the volume of the sample. And final thing which we had, what we had 10 ki power 3 divided by 10 ki power minus 3, that is 10 ki power 6. So finally what I will do, I will multiply it by 10 ki power 6. So the final answer will be 1740. The one who were saving unit conversion ml to meter cube. Why I'm not converting into meter cube, I am converting ml to, sorry, liter to. Did you get it? What I was explaining? I'm not converting in ml to meter cube. I am converting into ml to. Okay, you got it. Good. Stop sharing. So I think we. So what I was saying that so like similarly when we have to talk about the volatile, so generally at 550 degrees Celsius we see the volatility condition. Okay, na. So we have to deal it with the 550 degrees Celsius. At 550 degrees Celsius, the initial so final volume was 1.842 gram, and we have the initial value. So remember, like what will evaporate or which one will become, so after, so we have three stage. One is the blank thing. Sorry, where did it go? Pain. One thing we have, this is blank, then after 105 and after 550 degrees Celsius. So what will, whatever in has something has happened between this thing, so that has been evaporated or that has vaporized, not evaporate, that has vaporized due to high temperature. So that will be considered as volatile solid. Okay. So finding volatile suspended solid. So first you have to think that it is talking about suspended solid, so you have to talk about the filter. So on the filter paper, and again they are talking about volatility, not everything. Okay, na. So you have to just consider between 105 and 550. So this is at 550. Sorry, this is at 550 and this is at 15105. So something has vaporized. What has vaporized? A volatile solid. So again what we will do, that 1.924 minus 1.840 divided by 100 ml, and again we will do that calculation, and you will come out to be known that suspended solid is volatile suspended solid is 820 milligram per liter. Again here the same thing, calculate all the numerical value divided by and multiply it by 10 ki power 6, because we know that gram per ml into milligram per liter is 10 ki power 6. Okay. Now they are talking about total solid. Remember, total solid. What will be the total solid? Total solid will be total suspended solid plus total dissolved solid. I hope this is so. Like the filter was talking about suspended solid. This crucible was talking about suspended solid, dissolved solid. So when we do some calculation on this, we will get the dissolved solid. So dissolved solid will be solid retained in the crucible. So that on the crucible, what we have at initial volume was this much. After 105 degree, this is the volume. So this is blank crucible, so this contains solid plus crucible at 105. So if you take the difference, you will get as TDS as 1260 milligram per liter. So total solid will be TSS plus TDS. So it will be total will be 3000 milligram per liter. Any doubt in it? Anyone any doubt? Organic component, yeah, or organic component volatile vaporize, yeah, that is, so that is itself cleared as a volatile solid. So this was for so actually I have more questions but I don't have time. So you can look into this PPT that will be shared to you. or so this is my email id and this is my LinkedIn account. So if you anyone wants to contact me for anything related to mtech, phd or anything, you can contact me, or any doubt related to what I have taught you. I have like I might during explanation of MPN I might have explained something that is not related to course, but you will understand it if you are doing masters or PhD, or if you are explaining someone how this if someone asks you how this MPN table is coming. So you have to like if you have to explain what is MPN. So the most answer is that it is related to probability. Now you have to explain how this probability is coming and everything. Let's not go into that. Remember Thomas formula and MPN table. That's all. How MPN is found using MPN table or Thomas formula. If you have to go in the deep, then you can explain those things. Poisson distribution, then probability and all these things. Okay, so that's all for today. If you have any doubt, you can ask right now, or I will be ending the session. Any doubt to anyone? Anyone? No, no doubt. Okay, I hope you have understood everything that I have explained. Sorry if something has gone. I was not able to explain, but you can always ask me. I think I explain like whenever someone asks me, I explain in very. I don't know whether I'm able to explain or not, but I think so. That's all for today. See you next Tuesday on week 4. And if you have any doubt, you can like we can discuss about the previous week also. Okay, so I am ending the session. So like you have to leave because just thanks for your fun. Thank you. Tata.